Next, I'm excited about this presentation because I got a little sneak peek. I'm going to welcome Sam Lucero to the stage. He's the Principal Senior Analyst at IHS Markit, and he's going to dive into industrial IoT, robotics, and AI.
Well, good afternoon, everyone. So I'm going to talk about IoT and the intersection with AI and robotics and what that means for industrial automation. Okay, it's not changing down here. Oh, okay.
So I can go over some housekeeping issues. As soon as Sam's presentation is done, we'll have two more case study presentations, and then we'll filter right into those one-to-one meetings in the afternoon. All will take place.
Okay, great. So this is essentially the flow of my presentation, talking about how industrial automation and AI and robotics link up. Hopefully we'll have time for some Q&A at the end. So we're all here, obviously, because of this concept of digital physical fusion, the basic idea that we are integrating communications and computation into an ever-widening array of physical infrastructure, equipment, devices in our bodies, and the physical environment. And essentially, the digital domain is incorporating a nervous system, IoT, limbs, robotics, and a brain, AI. It's essentially becoming a much more integral part of how our physical world operates. In an industrial context, this is essentially Industry 4.0, with the first industrial revolution being mechanization and other revolutions giving us mass production, automation, and now cyber-physical systems. So the terminology is still somewhat loose in the industry. Different terms are used. So what is the difference between, say, Industry 4.0 and the Internet of Things? Well, if we take a typical supply chain, say one for laptop computers, IoT is fundamentally, in my view, really about what happens on the premises in an industrial context. But increasingly over time, there's interconnections happening with other links in the supply chain. And that maps to Industry 4.0 in the sense that it is a connectivity fabric enabling things like digital thread. But Industry 4.0 or smart manufacturing, industrial internet, are really a set of broader concepts than the Internet of Things. So digital twins, additive manufacturing, AI, machine learning, robotics are part of that more overarching Industry 4.0 concept. So Industry 4.0 is fundamentally about efficiency and revenue, primarily. You could add in worker safety, you could add in regulatory compliance, improving customer perceptions and relationships. But at heart, the first stage is about efficiency in the sense of many of the use cases that we've been talking about here at the show around predictive maintenance, supply chain optimization, process automation, and increasing revenue. So more efficient support for maintenance contracts or being able to provide maintenance contracts as an addition to a more traditional product transaction revenue model, and being able to incorporate more automated customer research and feedback into product development processes. So, for example, Coca-Cola is a tremendous user of IoT and Industry 4.0. technologies and systems and processes, and they actually launched a flavor based on the feedback that they were getting from smart vending machines, connected vending machines that allowed them to monitor actual transactions, actual sales of different test flavors, and they were able to make decisions based on that type of data. So this is the first stage, but looking further out, Industry 4.0 on the efficiency side is really trying to drive toward mass customization. So a batch level of one. And then on the revenue side, being able to change from simply adding on service components to an existing business model to actually changing to as a service type business models in the sense of going from, for example, selling an aircraft engine to providing, or say a gas turbine, and moving from that transaction to instead providing energy from the device under certain service level agreements. So a complete reformulation of how that company, how that manufacturer is making money. So right now we're in a process of moving from closed proprietary systems to open federated systems. Examples of this are Industrial Internet Consortium working through their I3C program to really try to take out the friction, the pain points that are holding back interoperability between different companies, different entities. And their work collaborating with 1M2M. 1M2M, for those who don't know, is a sort of collection of global standards bodies that are working to really formulate a service layer, a standard service layer for the IoT. Intel, and again, these are just examples, but Intel recently introduced a technology that helps it to really reduce the friction of installers having to manually authenticate devices in the field. It makes it much more of a drop ship, seamless operation for companies looking to install devices remotely. Or companies like GE and PTC ThingWorx setting up application marketplaces that allow third-party companies to come in, develop applications based on their platforms, and then providing that to their customers in an open marketplace. And the thrust of all of this is really to try to move from these siloed intranets of things, which is essentially where we are now, to a much more true sense of an internet of things. Actually, one of the most interesting companies that is moving towards this is a Dell investee called Autonomy, which is creating a marketplace for all of the data being ingested from cars. And Autonomy is normalizing the data, anonymizing the data, and entitling that data, entitling users of that data. And it's initiatives like that that are really going to make data something that is actionable by a wide base of third parties. So think of it almost as the shift from BlackBerries to the iPhone. That shift that changed the model for phones from a closed platform, a closed device, to an open platform that allowed the innovation from thousands, millions of developers. That's really the inflection point that caused the smartphone market to become what it is today. And I think that is the truly disruptive event that's going to happen with the IoT. Right now, we're still in a BlackBerry phase, and I think we're still trying to move to a much more open way of dealing with data. So key challenges, it's obviously still very complex technically to develop IoT applications, and many of the platform providers here and system integrators are trying to take that complexity out of the development process, abstract that away from developers. I think that's an absolutely key function, a key necessity. Business cases are often difficult to ascertain. That is something that holds back initiatives. It often requires cooperation from external parties, whether those are regulatory agencies or customers that may need to change how they interact with you, or suppliers that may need to get on board with how they are working with you. There's still fragmented technical standards, and that may more or less hinder development. I know that I believe it was Clearblade that was talking about how opening up and making open source their connectors and adapters was a key approach that they were taking, and I think that is something that hopefully more vendors will do. And then cybersecurity. Cybersecurity is repeatedly a top concern in surveys that we do and surveys that are done in the industry more broadly around IoT. So industrial automation, just to put some numbers to this, industrial automation technology is widely adopted now. But again, this is more of the BlackBerry model, right? So we still haven't broadly made that change to really being able to take data and federate it and title it out to third parties for new application developments. Briefly, AI is an evolving concept. It's a topic that's come up in this forum repeatedly. It's essentially, in my view, cognitive emulation by machines. Currently, the domain space includes natural language processing, very prominently strategic gaming, autonomous driving, image recognition. And AI, it's almost hard to underrepresent the significance. Kai-Fu Lee is a very prominent Chinese technologist, 50 million followers on WeChat, established Microsoft China in '98 and Google China in 2005. And he, through his venture arm now, is very focused on helping to encourage the Chinese AI scene. He was just at MIT talking to about 300 Chinese AI students and encouraging them to go back and to participate in this real flourishing that's underway in China now around AI. Bringing it more closely to industrial automation, AI, I think, is going to be very, very central to this ultimate goal in the industrial space of getting to mass customization. So currently, IHS doesn't size the AI market, or at least the industrial portion of the AI market, in quite the same way that we do equipment, but we can look at proxies in the sense of digital assistants and looking at the gathering momentum of assistants out there in the market and the partners that are being tied into these assistants. And if you just look at the trend over the past few years, very clearly AI is becoming productized and commercialized by a number of very significant companies. So quickly, some key AI enablers I'd like to talk about are processors, AI as a service, and the investment that's going on. So processors are becoming specialized for AI, and this is a key development. So starting from just taking general CPUs, a key shift was shifting to GPUs, which allowed for the parallel processing that is at the heart of these machine learning, deep learning systems to be done much more efficiently. So as an example, there was, the famous training by Google of an AI to teach itself how to recognize dogs and cats by watching YouTube videos. Took 2,000 chips to do that. That task or that learning was replicated on 12 GPUs. And currently there is a lot of work underway to make chips that aren't just general purpose graphics processing units, but to actually develop chips that, for example, model human synapses or really reduce the energy requirements for AI use cases. The tensor processing unit is a Google component. It's what powered the DeepMind AI that recently beat the world's leading Go player. Incidentally, the Godson 3C and Cambricon are Chinese chips, with Tensor and Apple obviously being US. So AI as a service, there's increasing support for machine learning as a service from leading cloud providers. These are just some examples, many others, but Google, IBM, Microsoft, in addition to open source tools and frameworks that are being used to develop these systems. And third, there's a tremendous amount of innovation. There are numerous AI startups being spun up, being acquired, companies making these investments, Baidu, Amazon, Tencent, Microsoft, Samsung, and many others. Now, AI is not without risks. I really hope Marty is right about AGI, artificial general intelligence. I really do, because my own personal view is I don't think we are ready as a society to deal intelligently or safely with AGI. So hopefully that's off in the distance. In the short term, issues that we as a society will need to grapple with, potential unemployment, bias, discrimination, finding its way into these algorithms that are being developed, and privacy. As you're taking all of this data and being able to analyze it at speed and much more in a much more fine-grained manner, what that reveals about us on a day-to-day basis is going to likewise concurrently become much more fine-grained. Even now, there's a famous case with Target. Just through analyzing purchase patterns, they sent a notice to the home of a adolescent girl. It was coupons, I believe, around baby items, diapers and whatnot. And the father became very irate. Well, turns out Target had accurately predicted, based off of the purchase patterns, that the daughter was indeed pregnant. So that it's already starting to happen, and I think that just with AI becomes much more of a societal risk that we are going to have to grapple with. Robotics. Robots in an industrial context have been a mainstay of factories for decades. The key shift here now is that we're moving from these very static and fairly dangerous devices where you really needed to keep humans away, and if you needed to make a change, it was weeks to make that change, to devices that are able to be taught much more rapidly in conjunction with humans, able to participate on the factory floor with humans in a much more safe manner, and to have any new skills developed taken and transferred out and used in other factories by other robots. Very quickly, as with AI, we think that Asia is on track to outstrip other regions in the adoption of industrial robots. So China has, for example, a policy, Made in China 2025. It's a central government initiative, and it wraps in the idea of industrial robotics, AI, Internet of Things, and really with the goal of making China the center of these new technologies going forward. So if you're not really, if China for these technologies is not on your radar screen, I'd really encourage you to take a look at what's going on out there because it's extremely impressive. Thank you. I think I may be out of time, but maybe one or two. Oh, 4 minutes. Okay, so yeah, maybe a question or two.
Sanjeev, you have one?
Yeah,
Here you go. Here.
maybe a comment actually regarding data from China. I work at Ford actually, and I'm working on some of autonomous vehicle and connected vehicle initiatives there. And we are global. And we are selling vehicle in China. And we have connected vehicles in China. So challenge is like, I don't know, you heard in the June, they had come up with new security policy. We cannot bring any mobility data out of China anywhere actually.
Mm-hmm.
And so being IoT, all these devices generating data, how we will manage the data? Do we keep every data in China or how it will work out?
China does have fairly strict regulations about keeping data in country, and I don't know if there's really a workaround to that other than setting up data centers in China. I mean, that's what I believe Apple's in the process of building Chinese data centers now. I don't know if there's any really other way around that. That kind of localization happens in a number of countries, Brazil, India, I think Turkey, Egypt, examples where you really can't take that data out of the country. So, yeah, I don't really have a suggestion other than the data needs to stay in country.
All right, I'll just share some information since you talk about that. I was there actually in the past May. They have the Big Data Expo, one of the largest. So I appreciate what Sam said. So over there, the cloud, they actually built several cloud. Like here, we have Amazon like cloud, or Azure, or Google GCP. Over there, they're about like 10, same size. So in terms of the capacity they're building and the storage facility they have, it's enterprise grade thing. And secondly, it's a phenomenal over there, the massive market, as you mentioned. The AI over there is like a norm. I was impressed. You know, they talk about AI. They do facial in the expo actually. When the people coming, they do facial recognition. Mm-hmm. And when you go to different meetings, right? Because they have the expo stuff, people wear RFID. They don't need to scan you or something. They know where you are, which session attend, and give the report. You know how many people attended this session, what kind of things. So it's amazing. I really appreciate it. As you mentioned, the data issues. I think that Amazon is trying to build a cloud, but I think they already left behind because there's a 10 kind of that level of cloud over there holding the data. But the innovation, the momentum, the kind of like driving a lot of, there are several reports over there. You show the statistics, it's phenomenal. To me, it's good, right? Because we are motivated. For the Silicon Valley, for the second Silicon Valley, Seattle, how do we actually, from US perspective, keep pace, compete, right? Motivate each other and move this whole thing to the next level.
Thank you. Thank you, everyone.
All right, thanks, Sam.